my name is Johan. I'm working at Mecanoo Architecten, and I want to start off with a small challenge. Which one of these images you guys think is real, or which one is the render? It's quite difficult, right? Our renders and reality are going ever closer together, and the one with the power line actually is the real one. But this shows what our industry is currently doing. We have new technology and media that's affecting how we actually communicate our space, our visuals, and they're getting more immersive. It changed our communication and our designs, and everything is getting more realistic and immersive. But what about the process of creation? Computers extended our productivity, they automate design tasks, they improve collaboration, but we almost have to be computer programmers to harness their full power. Creating a design or a model is not as easy as Tony Stark makes us believe. And so my talk will be a bit about how technology can help to make our design process more intuitive, organized, and fun. So I already introduced myself, but I'm an architect and design technology specialist at Mecanoo. And I work with BIM, computational design, coding, and virtual reality to enhance our designs. And one of my mottos is the best way to predict our future is by creating it. So Mecanoo is an office based in the Netherlands. We were founded 32 years ago by Francine Huben. And we are working globally over the world. And we often collaborate with many local design institutes in doing so. So I currently have 130 fun and great colleagues, and we currently work on a variety of different projects around the world. So we work on both big and small projects, on ranging from housing to public buildings, from libraries, theaters to museums. So we are a creative office. So initial designs often start involving a brainstorming and sketching session. And wherever you look, there's always people in the office sketching. We use it everywhere. We use it to communicate our designs. Next to this, we use model making. We use physical models to test our initial design ideas and to see if they work. Model making, models often remain the star of an architectural exhibition and presentation. They are part of our traditional architectural deliverables, and they have been around for thousands of years, and they will stay here for many more years to come. But over the last 3 decades, we got introduced to many new design technologies. As an architect, you can now use many new different tools to help creating. This, for our industry, is a bit difficult because we are one of the slowest to adapt industries when it comes to new technology. But many studios still don't make full use of the power of computation and BIM in our designs. We can actually learn a lot from other industries because our complexity of modern buildings make these tools very high or very necessary to reach a higher quality. So when we look at the traditional design process of making a building, we have 2 routes. We often work from a 2D perspective and a 3D workflow, and then we focus on the physical documentation and creating models to communicate to others and to coordinate our designs. But the truth is, our creative process is never that linear. Often seeing the results as a designer, as an architect, you want to change some aspects of the design, often meaning we have to redo some of our work, often leading a messy, sort of inefficient process. The architecture industry is famous for design alterations and working overtime to cope with these problems. So what we try to do at Mecanoo is we go for a virtual design approach, where we try to keep everything in one digital environment, where we digitally test and update our designs, and then generate the deliverables automatically, let the computer take care of the version control and documentation process, and help us in coordinating these buildings designs. So this will greatly speed up the process, giving us more time to design. So at the heart of this workflow is BIM. When I'm talking about BIM, I'm not talking about 3D, but I'm talking about multidisciplinary collaboration, using one data source of information, or latest information, and less management to get everyone to access that information. it integrates many of our other design technologies, and it greatly speeds up the drafting and the designing of a building, but it's a bit complex to fully implement and to use in your organization. So our BIM adaptation started in 2007, when we won a design competition for this theater in Kaohsiung, Taiwan. And back in 2007, the BIM software was not mature enough to both document and make these kind of geometries. So we initially started using Grasshopper and Rhino, and later we transferred to Digital Project and to Revit to share all this information with all our local partners. And this proved very helpful for the construction documentation. All the disciplines could get their information from these models, and we all collaborated in a digital environment to prevent a lot of the data loss. So when we when we have these kind of valuable models, we can also use them for digital fabrication. So what we did here is we collaborated with the shipbuilding industry because they already have technologies that convert the 3D data directly into a productive or a production process. So we used shipbuilding technology to make the skin of this building. So this building has been under design and construction for 10 years, but it will be complete at the end of this year. So, and since like the start of the BIM process, we have made a full BIM transition, and projects like these, they now make full use of this BIM transition. So what we try to do here is we keep everything in one database. So nowadays we only work with Revit, and we keep all our computation, geometry, data accessible for all partners in this platform, and then we use it to publish to other BIM platforms. So this greatly helps us in documenting and specifying the buildings. We can help the manufacturers to get the data out, but it also helps us as designers because when we model these kind of detailed models, it allows us to virtually test the models before anything gets built. And this results in extra deliverables that we can generate more easily, renders, animations, and all sorts of data that can help our partners understand what we try to achieve. And today, 90% of our designs are done virtually using BIM. So this is Kaohsiung Station, where we originally partnered up with a local firm that did not work in BIM, but we continued doing so. And we added all the coordination information in one 3D model, and that we used for virtual analysis and getting all the valuable information out of this model. In the end, our local also decided to go for BIM because this model proved to be so valuable that they also made the transition. So it's useful for our own design coordination, but it also helps to quality control the design process. So nowadays we use BIM for cloud collaborations, we use it to generate 3D prints for our physical models and our studies, and we even use BIM during design competitions to enhance how we design during design. And with virtual reality now, we have a new technology to step inside of these designs, in these virtual models we're creating. We can communicate with the space itself, and we can interact and simulate with these spaces. And these are valuable tools for architects and designers. And unfortunately, it's still a new technology, so the tools are limited, and you have to be prepared to get your hands a bit dirty to be innovative and do something more advanced. So initially, we started simple, using Google Cardboards in 2015, and rendering stereo panoramas with the traditional 3D programs. And we made our own VR image portal at Mecanoo to be able to share and automate a sort of a secure environment that we can send out to our clients and people that we want to show these VR images. So this is a mobile virtual reality. It allows us to quickly take it somewhere, it's portable, accessible, and it's easy to add as a bonus to the traditional design process. And we use it a lot for clients and user demonstrations, or during promotion or special events, and to show people our designs. So then there's a big difference between virtual reality and 360-degree images. I think this already shows quite clearly what you're doing with virtual reality. You're actually able to interact with the space, and that's much more powerful. But to use this power, we need also different kind of hardware. And so right now we use the Oculus and HTC Vive in our office, and we drive these using virtual stimulators called the game engines. And these game engines, they are really powerful and they're going to be important for our industry as well. Game engines, they make use of the GPU power that we have in modern day PCs, and they are so powerful that they can house big environments and do the computation at the same time while still showing high-end quality graphics. They are more flexible and customizable than our CAD tools, but they're also hard to learn as a non-programmer. So right now we have different solutions out there that help us in the industry for creating live kind of graphics from our Revit models or other models. And they simplify the use of this power, and so like the top category is more of the one-click solutions to get information directly into a live environment. The middle category is more the production, where you see that software companies are already using the power of game engines to make it for construction management or to generate animations, professional animations. And the bottom category is Unity, Unreal, and Stingray. They are more on the creating the applications themselves, and it really depends on like your imagination, your time, and the amount of money you're willing to invest to what you can do with these tools if you have an idea. So in our office we use Enscape because we are such a Revit-based office. We use Enscape a lot for our visuals, and these are the images we get directly out of there. And we also use Enscape to quickly jump inside of our models in VR to do design studies. So initially our clients and designers, they're always a bit shy and they don't want to put on the glasses, but the moment they tried it, they're always very excited and they're gonna have another go with the glasses. And we use it to see more difficult kind of spaces to understand, like a double height space that you enter. Using virtual reality allows you to really grasp the scale of a space, to see, for example, a hotel room, which is often occurring from the perspective of an owner, or to see a classroom from a child's perspective. You can actually, with virtual reality, simulate being someone else. You can simulate that you're in a wheelchair, or you can simulate to be really in a different kind of context to understand the design from another's perspective. So in augmented reality, we can include the context. So this is going to be really powerful for the next years. It has a potential to digitalize a lot of our to interact digital surroundings to our virtual or to our real world. And it currently still is under heavily developed. So we currently have the HoloLens and the Meta 2, and the software that is used for this is still limited. So we have to wait some years for the hardware to keep up. And when we look at the design process, it's often looking like this. So it doesn't really involve a lot of traditional sketching anymore. You're often working on a computer and you're not really involved with the 3D model as you would imagine you'd be. So that's why I came up with the idea to craft these spaces. And I dream of a more immersive and intuitive way to actually design these models. So I want to bring some of the craftsmanship that I was talking about in the start of my talk back to our digital design tools. So I want to combine human intuitive interaction and communication with the accuracy and the automation power of computers. And this is why I came up with Archispace, which I developed in my own time for the last year. And I want to give a live demonstration of this to show you a bit of how Archispace would work. So then in here, I hope it works. We tested it yesterday. Okay. Can you all still hear me? Okay. So I'm going in my virtual space here. So I will look ridiculous, but I hope you guys understand what I'm doing here and what I'm seeing here. Okay. So this is how Archispace would look like. The idea is that you would load in a 3D model coming from any 3D program that you have as a designer, and you use that to play with the model, to play actual physical model and to interact with that space. So I built in some functionality like lighting studies that you can easily grasp. And by having these two controllers, which you guys see here and here, I can actually do things using gesture control. So I can actually scale up the space and down, and I make it much more intuitive to do it like this than if I would have to do this in a computer behind a screen. So let's quickly go to, ooh, I'm a bit excited. So in here, I have like a model which I want to use for a little case study. So let's say I want to model something. Let's make it gray. So you see how easy I just make things in 3D, because with the controller I can spatially interact much faster. So I can just take this object, drag it around, I can move it around and then scale my space again. I can use it to scale the objects down and up. I can make new blocks. And let's just model something here. So having sort of control over virtual reality, it allows us to go with different ways of how doing things. So I built in some optimization, so you can make only with 2 clicks, you can make a block. And there's different ways of actually dealing with this information. And I built touch controls in there to be able to interact with the objects like any normal ribbon in the modern day modeling programs would do. So I can keep modeling, adding stuff inside, deleting stuff again. And let's say I just make a little space here. Let's make a, let's quickly model this. By the way, everyone is still seeing this, right? I'm not doing this in my own, own little world. Good. So let's just add some other stuff in there. So the problem with modern day architectural software is that it's often very difficult to do something intuitively. As a designer, you often want to just try out something, and by having sort of a way to place the objects with your hand, it feels much more intuitively than you can do with any computer. So we don't have to rotate and translate things anymore. You can just rotate the object itself by just placing things, scaling them. So imagine doing this in a more technical program. This makes it very difficult to do things randomly. Then, okay, let's just add some other stuff in here. Let's add some chairs. So you see, the nice thing about modeling in scale is, as an architect, you're often used to modeling in scale, but now we can actually scale it up to see it in real life. So now this chair would be just here. Now I scale it up a bit more. To be precise, I can be, ooh, let's put it here. So this is 1-to-1 scale. So this chair here, you guys are seeing it. I can test my designs really virtually, and I can go in any depth. I can go into the model and do some changes. So next to that, I have some sketching tools I built in here. So imagine being able to connect your sketching, like the way how you actually design, and this sort of placement of objects with BIM information. So if I can get this information back into Revit and use this to create the path that I'm now designing, then this would be really powerful for designers to make this process more intuitively and not having to tinker around with buttons they don't want to touch. So often you also want to have reference images that you play around with. So this is just in 3D space here. And let's see, let's put some sketch in there. Ooh. So we can point out certain things that we like or don't like, and we just show it to others. So the idea of this, using a game engine, is you can do much more powerful ways of communicating, and you would have direct feedback. And you can ramp up this quality, of course, to whatever level you have or whatever hardware you would have. So it has a great potential to show this. Okay. Yes, I think that concludes my talk. So I have one final slide. Let's go there. So I think the future of our design tools will be more immersive, and they work much better together and more collaborative. And real-time rendering will help to make all of these things possible. And VR gives us designers a new way to connect to our digital worlds and to make this process more intuitively. I hope we are all not afraid of our technology anymore as designers and architects, and are more embracing this for the future to come. Thank you all.